Hey, Talpingalize Math and History, and we're going to learn about the two slopes on a graph. So, if you remember in the past few videos, long ago, we have been taking a look at y equals mx plus b, where your x is going to be your input, your y is going to be your output, and your m is going to be your slope, while your b is going to represent the y-intercept, or also known as the start. So when you graph and insert things into y equals mx plus b, it's called slope-intercept form, but you'll actually see a linear line on a graph. Here's an example. So, that equation you saw in the short clip, that was y equals 2x plus 6. While 6 is going to be your starting position or y-intercept, 2x represents your slope. 2 is the slope. X is your input. And y is your output. Anything that you will insert in for x, like 2 or 4 or pretty much anything, your y will have a different answer. That is basically what we have reviewed in the long time videos. But what happens if you find two slope-intercept equations? What are we going to do with these? So what we're going to do is try to have the two lines on the graph intersect with each other. And when that happens, we're also going to find where that intersects. Because you can't have two lines unless they intersect each other. So let's see what happens when we graph the two. Let's start with the green equation first. So we should have a starting position of 10. That's the b. And we should also have 3 as the slope, x as your input, and y is going to be your answer, whatever we put in for x. Let's see what happens when we put this in the animation in the next video. Let's see what that line on the graph looks like. That definitely starts at the lucky number 10, alright. Not only that, 3x actually represents something is moving up 3 and is going left 1. When you see the letter x as a variable, it's perceived as 1, 2, 3, 1. 1, 2, 3, 1. And when you make a line between the two, that is your slope. Remember, slope is rise divided by run. So you rise up 3 and you run 1. Because when you have an x, that's considered as 1. If you have a 3 over 5, that's saying rise by 3, then run by 5. Rise by 3, run by 5 again. It's basically climbing stairs. See what happens when we try to put the red equation in. Y equals 9x minus 5. And then we'll see where it intersects. So what we just saw in the animation on the graph is when the second line was added, the two lines intersected each other. And not only that, they intersected at 17.5. But how do we prove that? Not only we can actually graph and see where the two lines meet, we can actually also use an equation because these two equations equal y. This equals y, and that equals y. So what we're going to do is not only have two equations, but we're going to merge the two and try to find what x is. Because when we find what x is, we're going to be able to see what we insert for x, so the two y's can equal to each other, making the point 17.5, and see why it does that when you intersect the two lines. So, since the green equation and the red equation both equal the exact same y, what we're going to try to find out y is, we gotta find what x is, so we can insert that isolated x to find out what makes the two at y at the same point. So, what we can do is we can simplify this. What we're going to be doing is trying to find x alone. So, minus this by 3x, and we can minus that by 3x, we get 10 equals 6x minus that by 5. Because what we just did is basically try to get a step further to get x alone. What else we could do is, since that number right here is with a variable, it has to be on the other side. So we can add that by 5 and add this side by 5. We get 15 equals 6x. When we divide 6 by 15 to get x alone, you will need a calculator for this. 15 divided by 6, that is going to equal 2.5. So x alone, when you isolate it from these two equations that equal the same exact y, then we're going to have a variable as x is going to represent 2.5. There's one more step that we have to do when we have x equals 2.5. We gotta prove why the two lines intersect at 17.5. So we're gonna insert 2.5 in for the green equation and 2.5 for the red equation. So, here's our example. We have y equals 3 multiplied by 2.5, that's inserted in for x, plus 10. So 3 multiplied by 2.5, that is going to be 7.5. And when we add that by 10, we get y is going to equal 17.5. What about the red equation? So for the red equation, we had y equals 9x minus 5. Well, we're going to insert 2.5 in for x. 9 multiplied by 2.5 is 22.5. Then when we subtract that by 5, we get an answer of 17.5. So what makes the two equations intersect directly at 17.5? When you insert 2.5 in both equations, that helps the two lines intersect at the same exact place. And that's how you try to find the intersections of two slope-intercept form equations. I hope this video has helped you. Thank you for watching Taoping Airlines Math Industry. Like and subscribe.